Hello, and welcome to the flipped pH video. By request, I have had students asking for the video version of this activity, and so I'm going to go over it with you guys for those of you guys who want more information. So pH is a measure of the hydrogen ion concentration, and many times what you're going to see in my class and in your other classes as well is a simplified version of this sentence or this phrase. And the way that we write it is brackets. So the brackets indicate a concentration of something, and the hydrogen ion is H+. So what you're going to see me writing from now on to indicate hydrogen ion concentration is these brackets and H+, and that's what that stands for. So solutions from 0 to 6 are considered acidic or acids. A solution with a pH of 7 is considered neutral. And a solution with a pH above 7 is considered basic. So what we're going to look at is the hydrogen ion concentration now. And so when you look, when you have a solution that has a pH of 6, that means that your hydrogen ion concentration is equal to 10 to the minus 6. So that 6 right there and that 6 right there is what it's referring to. When you have a solution that has a pH of 2, that means that the hydrogen ion concentration is equal to 10 to the minus 2. When you have a solution of pH 9, that means that the hydrogen ion concentration is equal to 10 to the minus 9. So that 9 and that 9 right there is what that pH is referring to. When a solution has a hydrogen ion concentration of 10 to the minus 3, so that number right there is going to be your pH. So that would be 3. When your hydrogen ion concentration is 10 to the minus 5, then the pH will be 5, just like that number there, but without the minus sign. And then if the solution has a hydrogen ion concentration of 10 to the minus 7, then the pH is 7. So that number right there is your pH. So when you want to calculate the change in the hydrogen ion concentration, okay, you're looking at solutions at various pHs. So if we're going to go from 5 to 7, then what you would do is use the exponent. These are your exponents for your base 10. So you would say 10 to the minus 7 minus 10 to the minus 5. Now that negative makes this negative positive. So you're going to take 7 to 5, and that's going to be 10 to the 2. Now, in biology, we do this as factorials, okay, or as factors. Think of it like the absolute value. So if I were to ask you, how much does the hydrogen ion concentration change by, in this case, you would say it's a factor of 100, so 10 to the 2. You don't actually indicate whether or not it's increasing or decreasing by that factor. You just simply state the factor by which it changes. In this case, it would actually, since it's minus, it would be decreasing by a factor of 100, but we don't indicate that because these are usually grid ins. There's no way to indicate that it was increasing or decreasing, so we just say it changed by a factor of 100. Okay? So to go from 6 to 2, we're going to do 10 to the minus 2 to 10 to the minus 6. Again, negative, negative means that this changes by a factor of 10 to the 4. Okay? Don't indicate whether or not it's increasing or decreasing. We just want to know by what factor is it changing. So in this case, it would be changing by a factor of 10,000. Going from 10 to 4, 10 to the minus 4, 10 to the minus 10, negative, negative. This would be changing by a factor of 10 to the 6, which means it would change by a factor of 10 to the 6th. Again, you're not indicating whether it's increasing or decreasing. We're just discussing by what factor is it changing by. And then changing from 7 to 4, 10 to the minus 7. We're going to change by a factor of 10 to the 3. So that is 1,000. You don't indicate whether it's increasing or decreasing. All you're going to do is subtract your exponents, and then that number will tell you by what factor the hydrogen ion concentration changes by. Down at the bottom, where it says draw a heating curve for water, I have included this for you guys on your study guide on page 39. So this is a heating curve for, well actually this is just this is a heating curve for water, and what you're going to do is you're going to find out what temperature does water freeze at and what temperature does water boil at. So if you don't want to search the entire internet, I already have a picture for you guys. You can just label it on here. Hope this video was helpful, and I'll see you guys later.